thank you for joining us today. So yeah, I'm really excited again to be at the Dataverse Summit, and as usual, thank you to all the sponsors who make these events possible, and also the organizers, because without them, if this wouldn't be possible either. Yeah, today's session is going to be. I'm just working on an open source project that is called FakeXRMeasy, and always building on top of previous sessions. So I did the last session in Spain at the Summit event, where I was demoing some of the new functionality that I was working on. And today I'm just building on top of that one, expanding and adding some extra bits and pieces. So hopefully that will be useful. So let me just grab a couple of slides. Oh, before getting to there, let me share a few links so you can follow along if you want. So this is the open source repo of the sample code that I'll be demoing today, and there is a documentation about how to use fake XRM. So there's a brand new doc site that I'll be posting in here as well. And also pretty much like with the Dataverse client, for example, there is a transitioning guide about how you can migrate applications across the latest version. So there is a post about how can you, if you are using by any chance, yeah, I'm still sharing the intro screen. I'm just copying and pasting links to the docs. Yeah, thank you. I'll post that. I'll post all the links I have, and then if you want to double check, including release notes, etc. So now I'll be dragging something into the other screen, so hopefully you'll be able to see it. So can you see my slides now? I hope. Yeah. Oh, yeah, thank you, Norris. So before getting to the demo, a high-level overview, because there are
Hey, Jordi, quick thing before you start into the presentation. I'm still seeing your intro screen.
my intro screen.
It looks like your background, your machine background. It looks like.
Maybe if I go full screen now, can you see it? No.
No.
You know what? I'll get rid of OBS and then just share the screen directly. So let me try again. Is that any better now? Hello?
Hello. Yes, it's showing your desktop.
Yeah, I'm showing my desktop now. So let me just. Can you see these slides now? Sorry.
Ah, yes, we can.
Okay.
We can.
Sorry about that. Yeah, I'll be doing a demo about how, because there are basically two different versions of fake XRM. One that is meant to be used, because the main kind of issue, or not issue, is that we have the new Dataverse client and NuGet package, which is meant to be used for building .NET Core applications, and we can use that to building Azure functions, anything that is running .NET Core. But still, if you want to develop plugins, those still are running under the full, the .NET 4.6.2 target framework. So that means basically there is a time period where everything just don't run fully in .NET Core yet. Hopefully it will. But for the time being, we need to use the core assemblies NuGet package to build server-side applications like plugins, custom actions, or custom APIs, and we can use the Dataverse client NuGet package to build client applications. So, but with FakeXRMeasy, you can use it for both. So that's why we have make a distinction of two different versions. Version 2 is for the building or unit testing server-side applications like plugins, custom actions, or custom APIs. And also we use then the version 3, which is using database client behind the scenes to be able to build Azure functions and web API. If you have an open data API, for example, or if you were using or had MVC web applications like I do, for example, I was working on bespoke web applications before AVX was a thing. So we still have those in some clients, and the easiest thing to maintain and migrate across these applications would be to replace the backend using the database client whenever that happens. But still, we're using most of the front end because I'm talking about, for example, applications that had, thousands of unit tests. So other applications we can build Blazor, console apps, or for example, there were a couple of demos that we seen today about, for example, triggering Azure functions based on webhooks. So or maybe use a service bus that will maybe trigger an Azure function based on receiving a message, for example. So a couple of different scenarios where you can use this. So just to double check, to stress the dependency, the main difference is that V2 is using the core assembly, so the XOM tooling behind the scenes, and V3 is using Database client. That's basically it. So demo. I don't have so many slides today, so it will be hands-on, hopefully. But let's just say, for example, we have seen another session previously where, for example, wanted to fire an Azure function from a webhook. Like that is like outbound. An event happened in database. We want to do something externally. But it could be other way around. So, for example, you might want to an event happens elsewhere of a Dataverse that eventually creates or updates something into the database system. So, for example, imagine, for example, you're building a static app that you want to use to create a contact. Maybe they want to subscribe something, and maybe you can use an Azure function to create that contact into a database. But the front end is a static application, for example, or I don't know, it could be another application. But just to give you an example, say that an Azure function triggers, and then we want to create a plugin, and so we want to after the contact. Sorry, we want to create a contact, and after the contact is created, we want to create a follow-up activity. That's kind of a scenario. So we're playing with different things, and how can we approach this? In reality, it will be much more complex scenarios, but I suppose you can take these patterns and to apply it, you can apply those elsewhere in many different places. So I'll then go back into Visual Studio now, hopefully. Can you, I'm sorry, I mean, just make this full screen. Can you see my screen? I hope that's big enough.
Yes.
The text at least. So, okay, so the scenario is, when an Azure function triggers externally, creates a contact, and then a plugin fires, and then creates a follow-up activity. There is a functionality in the framework that's called pipeline simulation, which I'll be explaining in a bit, which we can use to trigger the execution of that plugin locally from the same Azure function unit test project. And that's really useful because it means basically we don't have to wait to deploy the Azure function to be executed. It means we don't have to maybe add log traces or logs into applications in sites, for example, to know what's happening in that plugin when that was triggered from an Azure function. It means we can debug the Azure function locally. And when you apply those things to a code base that might be, not trivial, then you can run thousands of tests at scale. without developing those things, or which would be probably very time consuming and therefore expensive. So before getting into that, let me explain how can we structure a project to be able to do that. So this is the source code for this is available in one of the links I was posting. So it's the samples, and so we have a solution where we have the function, and we have so we're using early bound entities as well in both the plugin and the Azure function. And you can generate those entities using, like, for example, say CMSBC util, or Albanian early bound, or Daryl's early bound generator. You have different options, but the point is we want to use early bound entities because it provides a way of coding that is strongly typed, so we prevent other issues like, for example, typing incorrectly a field name or things like that. Anyway, so I have those early entities already generated, like contact and task, which are the ones I really need for this. In this file that I have in here, which is generated code. And this is a shared project because I want to share as much possible, as much of the logic between both the kind of the client application, the Azure function, and also the server-side implementation, the plugin, so that I can, be able to use that pipeline scenario. So you can use shared projects like I'm showing you in this project. If you have, depending on the scale of the project, if you have everything in the one repo, maybe this is the easiest. If you have much bigger deployments, then, and you have different functionality, different code bases spread across different repos, maybe you might want to use, for example, source NuGet packages, or maybe Git submodules. But for the purposes of this demo, a shared project was more than enough. So so basically, we have a shared project where we have the early bound entities. We also, the plugin code is actually in a shared project as well, because we want to be able to call that plugin from the Azure function later on. And also and so these are basically two shared projects. So we have, this is the source code, and this is, I like to structure unit tests in a tests folder. That's personal opinion. You can do whatever. But then we have a unit test project for the plugin, and then a unit test project for the Azure function, as you can see. And this is more or less kind of the structure. Any questions so far? Otherwise, feel free to stop me, or I can just move on. So I'll move on. Pack also no supports generating the model classes. Yes, correct. So this is kind of the high level structure. So the way we would be approaching this is, for example, first of all, we need to create a contact from Azure function. So I would go into the unit test project. If you were doing TTT, you would be creating the tests first, but that would take me so much time. So I was just going through the code that was already written. So say, for example, so this is a, let me just run this one to make sure it's still working. So this is the unit test that would verify that whenever the Azure function is executed, it will create a contact. And so the main principle of XRMSD is that simulates Dataverse in memory. So rather than mocking APIs from scratch, it's based on state. So so we have an input state and end state per se. So the input state is something like simulating we don't have any data in Dataverse, and so after the Azure function is executed, we should have a contact in Dataverse. So that's how we approach this. So what should happen after the function is executed, this method to create a contact, then, well, it should succeed, but we then make a query against that in-memory database, and where we retrieve, oh, this is like, give me all the contacts that are supposed to be created, and then I'm making sure that at least one exists in that database, in that database. And also, I want to double check that the first name and all the fields that were supposed to be received from that Azure function, could be anything, um, are also received and stored in the contact entity. So the good thing about this is that I don't have to, spin up the host of Azure function. I can, as soon as I'm just building logic, I can put breakpoints. I can, start debugging this unit test. And if I then add a breakpoint into the Azure function, for example, go into definition, I can just go to definition. So, this is a method that is very simple. It's just creating a record, so it could continue. I can debug. I can inspect. Everything that I passed into the function. Let me stop that one for a second. So this is how we basically would be, you know, very simple scenario, very simple example of how to create a contact and to make sure it's created on the in Dataverse. So so if you can see, I'm using the Organization Services Sync 2, which is a new interface from the database client. So which means we can use async methods to do stuff. And when so the service client itself implements that interface directly, and many others, they sync as well option. But because that service client implements directly that interface, we can just pass it as a parameter. So this is how this would be kind of the body of the function, really. It would be just receiving the data via, for example, query string, and passing it into that method. And then when it comes to creating a connection or retrieving the connection, there are multiple options. I went for just for the sake of simplicity for environment variables, but you should maybe use manage identities. Anyway, but that would be just the authentication step, which happens at the very beginning. And then everything after this, you can just rely on the organization service and build any kind of logic as much as complex as you want, just relying on this one. So yeah, this would be the bit of code that would be different, really. So okay, so up until here, basically we have tested the Azure function. Um, can you hear me still? Yes, I suppose. So um, so we have let me actually run it so you can see it's working fine. The good thing about using unit tests as well, it gives confidence. You can start making changes as soon as anything is broken. For example, if I dive into the function and, for example, I forgot to pass in the first name. For example, if I rerun this one, then it would fail. All these things, as soon as I'm making changes as a developer, well, it is not even building, but say, for example, this was something like this. I can just make changes with the confidence of at least everything that was previously tested is not broken. I also debug those changes as I'm making those. So for example, that will fail because it was expecting something to have Joe, and it's not the case. So this is the value of using unit tests. So let me just go back to use the first name, and then running again. So that was, the unit test, the Azure function in that scenario was very simple. There was not something massively complex. What happens now? So now we want to test what happens on the back end. So that whenever we receive that contact that was created against database, that we can then there is supposed to be a plugin that will create a follow-up activity. So this is the follow-up activity plugin from the SDK from the Microsoft Docs. That it's well, this don't know is the one I don't want to show you yet. But pretty much like we had a unit test in the function, we have also a unit test for the plugin. So this is the unit test project for plugins. How could we do this? So for example, the follow-up plugin basically takes the contact as a target, and then it takes the ID property to know which is the value, because it needs to create a task and then assign it to the contact. So it needs the ID, which was received as an output parameter. So we need to indicate that in this plugin context property. So the way we would test and unit test would be like, what is the get default plugin context? This is like, so FakeXRM is able to mock the whole plugin execution context, and it provides you like a default implementation with default values. And then if you need to override anything, like in this case, I need to populate a property for the output parameter, and then that's the only one I'm setting in this unit test. If I had to, for example, the plugin was needed to do something based on the stage, if it's pre or post operation, or based on images and things like that, then we would pass those values into the plugin context. So basically, this is like in one line of code, give me something I can just use passed into the plugin directly. You have to very simple. And then only the things I need to override for that plugin to be tested, then is the things that I need to change. And pretty much the same approach again. So the input state is nothing existed again in the database because this is before the contact is created. So when you receive a contact in the target, then we make sure that a task is created. Then there is that at least one exists and that it matches the contact ID. So again, I can run this one. I can, if I was developing this from scratch, I would start from the test probably, and then I will just adding, the deploying logic step by step, and keep rerunning the unit test all the time to make sure everything is working fine. So again, if something fails in the plugin and I'm sure why it's not working, I can just put a breakpoint into the follow-up plugin, for example, and then I can debug it from right within the unit test. And again, I don't have to wait for the plugin to be deployed. I can make as many changes as I want. I can step into these changes and so on. So that's basically, so at this stage, basically, let's say we have tested, the Azure function and also the plugin code that creates the follow-up activity. So what happens next? Maybe it would be nice to also to be able to, maybe for troubleshooting, um, if something was not working properly inside the plugin, it would be really great to be able to see those things from the Azure function itself. So, isn't it, I suppose? So then there is another functionality in the framework, which is pipeline simulation. And what is pipeline simulation? Basically, let me show you this one. So this is, again, the unit test project has a specific configuration using a pipeline. So what this is doing, basically, that, say, for example, if you execute a service.create, if you had the plugin registered against the create message, it will just retrieve that plugin assembly and when executed, passing in the target. So you can simulate scenarios where plugins are firing based on different requests, and that could happen many times. So if there was another service.update somewhere else that was for which you had a plugin registered, then it will fire that plugin execution as well. You can combine these kind of requests to be able to maybe is kind of bringing some of the something that you would typically do in integration testing, but trying to mimic those while you're unit testing or building the solution. Yet again, try to mitigate any possible issues before, rather than waiting for after deployment, trying to do as many things as possible sooner. So this is what basically the use pipeline simulation would do. And how does this work? So being able to, in order to enable it, you just need to tell FakeSR, hey, I'm going to use Python simulation, and you need to stick it into the middleware, like before anything else, because it needs to know that when I do, for example, like a service activate, it will need to fire, for example, a plugin in the pre-create, so it needs to be before in the middleware. But yeah, basically, this with these two lines, you're telling FakeSR easy to use Python simulation. And I really like this structure because it's like declarative. By just looking at the one file, you have more or less an idea of how this, of how fake XRM is configured and how it's set up. I know it's using, CRUD, it's using some, messages and using Python simulation just by looking at the one file. It's declarative. I don't know. I think it's really useful. So going back to the project, uh, so how it will work under if we wanted to use simulation. So when we have Python simulation enabled, not just we can test the share function, but we can test whatever side effects happen because of that plugin execution. So for example, we could run the share function and also not just that the contact is created, but also from the same execution, so also that a task should exist, for example, and that is linked to to the to the contact. And how we tell fake XRM easy to fire certain plugins. So we use this syntax like here, which has been slightly changed. This before. So sorry, I'm talking too much. The register plugin step is like telling, oh, I have a follow-up plugin that I need to fire. I actually want you to fire whenever there is a contact that is created, and that's it. In this case, is very simple. You can have plugins registrations more complex than this. You can maybe also, have filtering attributes. So this will only run if some of the attributes in the entity were changed, or and sometimes, can you hear me? Yes. Sometimes basically my headset goes mad, so I'm just unmuting and muting myself from time to time. So sorry about that. So yeah, this is how we tell FakeXRM to fire a plugin. So once we have done this rather simple step, what we can do then is then whenever that creates contact happens, it will kick off the plugin. So let's show you how this is happening. So again, I can debug the whole thing locally. So what this is doing is, executing the share function, and because it knows that whenever I create a contact, it needs to trigger the follow-up plugin. As you can see, it's actually executing the follow-up plugin. And the good thing is I can step into the plugin, but the funny thing is that the original call came in from the Azure function, as you can see. So this is the stack trace. So the call stack, sorry. So I think this is very useful because you will be able to spot things, especially if the share function is more complex while you're developing stuff. Other things that we have in the framework as well is that the way I was actually testing this pipeline simulation functionality was to make sure to create some like a plugin auditing functionality. What is that? So the plugin auditing functionality is like, imagine, for example, when you're using n substitute or fake it is that when you are testing some logic and then you had some other logic that was tested elsewhere, you just want to make sure, okay, I'm just okay making sure, for example, that method was called with those parameters and that's it. So you could do something similar with plugin auditing. Rather than just testing that the task was created, what you could do instead is, well, I have an Azure function that is running and is supposed to create a contact against database. Rather than double checking again the same unit tests I had in the plugin, what I could do is I can enable plugin auditing steps and say, oh, not just the Azure function should create also the plugin, sorry, the contact, but also the follow-up plugin should run. So this is so you could do that with a plugin step audit. So let me show you how this was set up in the pipeline simulation, but it's as simple as just going to the pipeline options and setting use plugin step audits as true. And whenever you enable this, for every single plugin execution, it will store like a trace log if you want. And then you can query that trace and those executions, and you can say, oh, not just the Azure function had to be run, but also that, the follow-up plugin had to be executed against the create message, for example. And so you don't have to unit test again the same, the functionality that you had previously in the plugin. It would probably make the code base or for unit tests at least smaller, I think. It's not an option you can use. How do I know that the plugin state config unit test match what is configured in Dataverse? Yeah, I'll answer that question later on, Phil, because I didn't get as far as showing something really cool I just did yesterday. So one of the things that are not, so on Nougat there is version 2.2 right now, but there will be version 2.3 soon. And with that version, there is something called automatic registration. So rather than just doing these things manually, you could go into the pipeline setup, like this, and say, you know what, I not just want to enable pipeline simulation, but also I want to, for every plugin that I'm testing, I want you to register those plugin steps automatically, so you don't have to do that again from scratch. And how this would know about what to register. So a couple of options. The option that is there right now, and I'll show you in a minute, is using plugin attributes, for example. But this configuration is rather simple. It's like, okay, enable automatic plugin registration, and then look for plugins into a list of assemblies. Which ones? The ones where I know there are plugins, because if this was running possibly for any kind of assembly, it would make things really slow. So we want to limit the assemblies to look for plugins. And so you would just need to call this a single line of code for every. If you, for example, you were using two different assemblies, then you would need only 2 lines in here. And you can pick randomly any plugin from each assembly, and it will discover, those plugin steps registrations and how this is done. So if I go to the plugin follow-up plugin, it's using this kind of syntax. So like a plugin class attribute, and this is set up so you can have as many of these as you want. You can use also attributes for registering, for example, images, and this basically has different options. You can, specify the stage, message, mode, and entity logical name, rank, and filtering attributes, among other things. In this case, if I wanted to do the same thing that I was doing manually, the only thing I would need to do is, again, the follow-up plugin needs, which is this plugin, needs to run for the contact on create, pre-operation, and synchronous. And I really like this way of doing it because, first of all, it's sonic type. So if anything here changes, I can, or if I needed to change anything, I just right-click rename as opposed to replacing a bunch of strings. So it's a sonic type. Um, it follows the single responsibility principle because the registration is closer to the plugin, and it's probably a responsibility of the plugin to decide when it should run. So by just looking at the source code, you can see, oh, this plugin will be registered against with this configuration, and also it saves you from duplicating possibly the same on the unit test project. So it'll read from there. And then, in good point, Ben, which is anticipating that question. But the idea is that from this plugin step registration, you can use a tool like Sparkle to register those. So we'll keep those in sync. That's not yet there, but because I think Microsoft is looking into a way of possibly, using something like this to deploy plugins in a way maybe similar to this. But then if that happens, then you can use the plugin registration as the single source of truth, and it's code first. I add the registration in the plugin step, and if I have tools like Sparkle to then register those or deploy those using reading from this configuration, then this is the only thing you need to trust, and this is the only thing it will fit into the unit test project, and will make things easier. And not just that, but also in the fake XRM easy functionality, there is also something called pulling step validation. So for example, and say for example, when you're deploying a registration tool, you want to register a message against, you can choose different options, but it wouldn't allow you to do anything because obviously there might be combinations of these values that are not possible. Like for example, it's not possible to register a creates in pre-operation asynchronous because that would be like having a time machine going back into the past asynchronously to create something that doesn't exist yet. So, but the good thing about that plugin step validation functionality is that now that I have this enabled automatically, if I go into the plugin, into unit test again for that plugin, which I think was using this one, see what happens. So this one is failing now because there's something called, in fact, it's called plugin validation, and it's validating that if you attempt to register a combination of step values that is not even possible by the platform or by the plugin registration, it will fail. And you will notice as soon as you make the change from that one place, which I think is really cool. Maybe some of the developers that might be more experienced will know about these things, but not everyone will know maybe, or even all different combinations. Like for example, it's not possible to register anything against the absurd message, for example, so it will also fail. So let me just put back to synchronous. So if I run this one, then it's like at least passing the validation and saying, oh, okay, yeah, this is fine. Then we can continue. So so this is basically all the different functionality we can use. As I was saying, you can use different options to structure these codes. If you're using a single repository, maybe you can go for shared projects. If you have different code bases, you can go for NuGet's source packages. Oh, the thing that I missed is that you may be wondering, well, this plugin representation is coming from somewhere, isn't it? Because this is the plugin code. So this is coming from the from the abstractions package. So FreeXRM is divided, is broken down into different packages, and the abstraction is one that has these definitions. This eventually would work with dependent assemblies. But if we want to do this on premise, then rather than using this assembly, maybe you can just have your own method, or you can maybe, again, put the same code we have to discover this plugin steps, which is not very complex, into a shared NuGet package again and use it. There are a couple of options, but this is how it's done. If you go the simplest option, if whenever the dependent assemblies are production ready, I think they're not yet. It's still in preview. I might be wrong, but then you can use that, because the abstractions package is very simple, a very small package. It's a few kilobytes, so it's like nothing. So you have to install everything. Just it will install the registration steps with all these different animations, etc. So you have to do those from scratch. And how deep the pipeline feature will run, Jordi? For example, show function calling contact from one of the contact good another update to another entity. I didn't test the that level of deepness. For example, one of for sure the things that are not behaving like the platform, for example, is the maximum loop, which I think is 8 iterations. Is that is not there? We might add it so we can simulate the same thing, for example. But yeah. So it's like 42 minutes already. So I might go for questions if you have, because I wanted to leave like 10 minutes plus something for questions. But basically, to recap, the session would be like we can use FakeXRM for both server-side, for client applications. The value of embracing unit testing is that you want to spot, those issues before they happen, not even in production, but also on a test environment or staging. That I also tests have loads of benefits, like it's living documentation of the project, and so on, things you probably already know. So
Thank you, Jordi. Thank
cool.
you. So there are questions in the chat. So the first question is from Mayank. So Mayank, actually no, the first one, Phil's done a little poll there. Do you use unit tests in your code, in your projects with C#?
So does it maintain plugin def can be used to avoid infinite loop scenario? Not yet, but I'll think of adding it for a future release. Good point. How do you know that the plugins they configure match what configured in database? This was a good question. So one thing of making sure the matches is using like a tool, like maybe Sparkle, to register those based on the same attributes. But say, for example, this plugin step, this ID, when you create a plugin, is stored in the SDK message processing step entity behind the scenes, which has a primary key. We can use that primary key to say, in future, for example, you just want to enable this for a pre-existing implementation where you had already registered many different plugin steps. You can read from the same entity, populate the same ID, and so whenever that tool registers the plugin steps again, it wouldn't create, for example, a duplicate registration, for example. That's one way of doing it. So when Molko was saying we could use the Sparkle to infer plugin registration, yes, exactly. And it should be possible to find source code, and if it's source code, then it shouldn't be possible to modify the plugin registration tool. I agree, because then, as we're saying, it's important that if the plugin attribute drives the registration, then you could use that as a single source of truth, the thing that you can trust. Similar question again about the deepness of the pipeline. So yeah, there's no limits right now. I'll think of adding it. So it would better, simulate the actual behavior on the platform. And that's it. Do we have any more questions? No.
There's some great comments in the chat here. So yeah, so as you rightly mentioned,
yeah. I probably went too far. Oh, sorry, too quick explaining. I didn't want to write any code because it would take ages. I would need probably 2 sessions to write everything that I wanted to show. So that's why I went to just flying through existing samples. But
thank you, Geordie. Yes. So Geordie, can you hear me? Hello. It sounds like Geordie can't hear me actually. 1 second. Hello, Geordie, can you hear me? No, sounds like you can't hear us actually. So what we'll do, let me type in, hi, Geordie. Can you hear? Yep, so Geordie can, okay, he's hearing the response. Well, okay, seems you can't hear me. Okay.
hello?
Hey, can you hear me now, Geordie? No?
No.
Interesting.
I can't.
Okay.
So,
so let's say thanks for your session. Oh. So Geordie's having some audio issues, but at least he was able to do his session today.
I can hear you now.
Okay, Geordie. Great stuff. Awesome. Well, thank you for your session, Geordie. And we will, I think you've answered all the questions, so thank you so much. And hope to see you in person next time.
Yeah, I'm really looking forward to that.
Definitely. We're all excited to see you very soon. Betim, I can see Betim online. Betim is one of the biggest proponents of fake XOR Easy, so it's great to see Betim online as well. I also saw Ben Walker as well. Ben Walker's been a high, one of the power users and someone who's contributed a lot. So it's great to see Ben online today as well. Thank you guys for contributing to the unit testing frameworks for Dataverse. Thank you all. And Geordie, look forward to meeting you in person very soon again.
Yeah, meeting you. It's been a while. So yeah.
Definitely. Really look forward to that. So thank you, Geordie. And we'll move on to the last session of the day.
Thank you, guys. Take care. Bye-bye.
Fantastic.